What's up, my friends? We've been working on volume of prisms, and then we learned how to do volume of a cylinder. Okay, so the volume, still the same thing. How many cubic units can fit inside of a three-dimensional figure? And you can kind of see that below. This one, they didn't completely fill it out for those parts that didn't fit, but if they were there, we know it's going to be that relationship with pi. That's why we get that decimal. But a cylinder is that three-dimensional figure with two parallel circular bases, right? We know what cylinders look like. Cans, some water bottles and thermoses, stuff like that. So our formula for the volume of a cylinder, we do area of the base shape, which is a circle, multiplied by the height of the, prism, I should say, cylinder, height of the cylinder, how far apart those circles are, okay? From the bottom to the top, sometimes they're on their side. Don't forget that we know the formula for the area of a circle. It's pi r squared. So I'm looking here at this example. Okay? They gave me radius. All right? So my radius equals 3. Just good practice to say that that means my diameter is 6. But, so I'm getting the area of the circle. That's pi r squared. So I'm doing 3.14, my point should have been there, sorry, times 3 squared, times 3 times 3. So I'm doing 3.14 times 9. I'm using my calculator. 28.26. Hopefully this will still let me write. Yeah, there we go. 28.26 inches squared, because that's the area of the circle. And now I take that amount and I multiply it by the height of the cylinder. So I'm doing 28.26 times 10. Oh, that's nice. Times 10 means the decimal just moves one time. So that's approximately 282.6 inches cubed. And that's the volume for that cylinder. And now time for that second cylinder. So notice how it's on its side. I still have to get the area of the circle. It's a cylinder, right? So this one did not give me radius. They gave me diameter. Okay, they gave me that distance straight across. So my diameter is 6.4, and my radius is half of 6 is 3, half of 0.4 is 0.2. Okay, 3.2 centimeters. I need to make sure I'm putting those measurements on. Still the same process. I'm finding the area of the base shape, the circle, multiplied by the height of the cylinder. So I'm doing pi r squared first. Pi, or I just want to do 3.14 times 3.2 squared. I don't know 3.2 squared off the top of my head, so I'm using my calculator. 3.2 times 3.2. Really? Yeah, actually that makes sense. 3 times 3 is 9. It's 10.24. Sorry. I got that and I thought that number would be bigger, and then I was like, no, that makes sense. 3 times 3 is 9. So it's 10.24. I still have that number in my calculator, so I'm just going to do times 3.14. And that's, it's a longer decimal, but that's okay. Approximately, because remember if I use pi, my number would be a little bit different. 32.1536, and this is centimeters squared. And then the last thing I do is multiply it by the height of the cylinder. So I'm doing that 32.1536 times 13 for my approximate value. It's still in my calculator, which makes it so much nicer. I can just do times 13. And it's a longer decimal again. I can round this though. I'm going to round it to the thousand, to the hundred. But I'm going to write it out first. So it's 417.9968 is what my calculator gave me. I'm going to round it to the hundredth, which means I look at this number. I look at the 6. 6 is going to round my 9 up to a 10. So that would mean that this number gets rounded up one more. But that's also going to be a 10. So this rounds to 418.00. Be careful that on like state testing or anything, if they ask for the 100th and that happened, they would want those zeros. Okay, so this is centimeters cubed. That's how you solve for the volume of cylinders when you have radius or diameter. Okay.